Okay, Assalamualaikum and good afternoon. Okay, so we start the class with the quiz. Okay, so basically you will be given about 30 minutes to answer your quiz, and then another 10 minutes to submit your quiz to the Google Classroom. And I need a PDF form. When you upload your answer, I need the PDF form lah. Okay, do not send me a picture because it will be a problem when I mark later. Okay, so I will share the question in Google Classroom. Sekejap Okay. Okay, so the question already in Google Classroom. Please on your camera so that I can see you during the quiz session. Thank you. All of you, please on your camera. Okay, and then you can start with your quiz. So we finish quiz at 2:35. Good luck. Okay, the question also in group WhatsApp. You can answer in that or you can have another paper for your answer. It's up to you. Okay, time's up. Stop answering the quiz and you can start with the submission process. So I give you 10 minutes to submit through the Google Classroom in PDF form. So after 2:45, I will consider it as a late submission if you submit after 2:46. Okay, so stop answering and start the submission process. After you submit, you can off your camera, so that you can save lah the data. Okay, so let's start our class. Okay, so today I would like to discuss the 1.4 and also 1.5. Okay, so with that we finish chapter 1 and then we proceed to the chapter 2. Okay, we discuss a few things for the chapter 2. Okay, so I expect that you already done the exercise. Okay, so that we will discuss through the exercise. Okay, so we go to the 1.4 first. Okay, so under this subtopic, it is about how to draw the box plot. Okay, so I guess the plotting part, the sketching part, you can always watch the video. Okay, there is a step to plot the box plot. Okay, and but for the assignment, it is compulsory to use the Microsoft Excel. So that one you can find out by yourself lah. Okay, how to do it in Microsoft Excel. Okay, so what I want to highlight here is how to interpret on the box plot. What can we comment based on the box plot? What kind of the informations that we can get from the box plot? Okay, so okay, so sekejap, Okay, so the box plot, it is about 5 number summaries. Okay, so those 5 number summaries, you have minimum value of your data set. You have the Q1, okay, in first quantile, and then you have the median or the second quantile. So you can use the formula of the median, or you can use the formula of the Q2. Similar, it is about 50% of your data, half of your data. And then we have the Q3, and then we have the maximum value. So this is only value that we plot in our box plot. Okay, and another value that we plot is a outlier if exists in your data set. Okay, so it is about 5 number summary and also outlier if exists. Okay, other than that, we do not plot in our box plot. Okay, some student, okay, they will get confused, okay, with the lower limit and upper limit for the outlier. Okay, so in order to identify whether we have the outlier or not, it is based on the lower limit and upper limit that we calculate. Okay, that one you should know lah if you already watched the video. Okay, so we do calculate the lower limit and upper limit to check for the outlier. If there is a data value which is exceed both limit or maybe one of the limit, then they are the outlier. If all the data values stay within the limit, then there is no outlier. So those limit we don't plot in our box plot, okay? Because box plot it is about 5 number summary and also the outlier, okay? So you can have the vertical box plot or you can have the horizontal box plot, okay? So horizontal box plot means that we use x-axis as our axis, and vertical box plot we use the y-axis as our axis. Okay. So when you construct the box plot, it is suggested to use a proper axis. Okay. Proper axis means that you have to determine the range of the value of your axis. Okay, make sure that you have same range for the value so that your box plot will come out nicely lah. So it will be easy to see or to determine the shape letter for your box plot, and also to determine the consistency of your box plot. Okay, consistency of the box plot we can determine by the variability or by the size of the box of your box plot. Okay, if you have smaller box, let's say that we compare two set of data. Okay, we have set A, we have smaller box than set B, then we can say that set A is more consistent than set B lah. Okay, So other than we calculate the probability, we can determine based on the size of box. Okay, this is what I meant by the size of the box. Okay, based on this size, we can determine whether we can discuss the consistency of the data. Okay, but you have to draw properly. Okay, properly means that you have proper axis. If not, then your judgment could be wrong lah. Okay. So start how to construct. You can watch the video. What I want to highlight today is just the interpretation. Okay, what kind of information that we can get from Boxplot or how to comment on the Boxplot because it is in your assignment. Okay, so take note. Then it will be okay for your assignment. Okay. Okay, so exercise 1.4.2, question 1, you have A and B. So A and B here, we have single set of data, means that we have single box plot on that axis. Okay. So you should get this one. If you try the question 1 here, you should get this box plot. Okay. So we have in this answer scheme, we miss something. Okay. So we should label our box plot. Okay, we have to label all the value that we plot. So here we have the mean, we have the Q1, we have the Q2 or median, similar thing. We have the Q3 and also the max here. Okay, if you have the outlier like the question B here, this is the outlier, then we have to label also. This is the outlier. Okay. The information that you can write here is a shape of your box plot. Okay, so shape of your box plot. So you can comment on the shape here. Okay, so you have right skewed means that most of the data concentrated. Okay, concentrated at the right of your box. Okay, because we have the right skewed, not the right, the left, sorry, the left of your box. Okay, most of data, okay, located at the left of your box because we have right skewed. If you have left skewed, then most of data concentrate at the right of your box. Okay, what you can write lah. Okay, about the based on the shape of your box plot. Okay. So, what to call? More information, okay, we can get when we compare the box plot. Okay, compare the box plot means that we do have more than one box plot on the same axis. Okay, if we try to compare the data set by using box plot, you have to construct those box plot on the same axis. Okay, so similar to your assignment. Okay, you have 4 set of data means that you need 4 box plot. So those 4 box plot must be on the same axis. It cannot be separate. Okay, because we try to compare those box plot. Okay. Okay, I ask you to do the question 2 here. Okay, hopefully that you already done. Okay, I will not touch on how to construct the box plot. That's yours. Okay, we go to the how to interpret the box plot, how to answer this question. Okay, so first thing, what is the variable of this data? Anyone? Variable of this data?
Measurement of flexibility.
Flexibility of the spring. Okay, flexibility of spring. Okay, that's the variable. So compare the distribution by using box plot. So it is clear that you have to construct the box plot here. So distribution here means that we need to know what is the shape of your distribution. So before this, we discussed 2 methods in order to know what shape that we have on that data. What are those methods? to determine the shape? Anyone? What are those methods that we use to determine the shape of your data before we discuss the 1.4 here? We have
Measure of center tendency.
measure of central tendency. Another one,
Histogram.
histogram. So histogram and also measure of central tendency. That's good. Okay. So another method that we have here is a box plot. So box plot similar to the measure of central tendency. We can have three different shapes by using box plot. Okay, so it is different. Histogram we can have about 8 different shapes. Okay, by using histogram. But box plot similar to the measure of central tendency. Okay, we just have three different shapes, which is left skewed, right skewed, and also symmetric distribution. Okay. So give comment on the flexibility of the spring supplied by the two different company. So we can comment on the flexibility of the spring here. Okay. Okay, so in box plot, okay, there is a two what we call measurement that you can use to comment for the box plot. The first one is an average, and the second one is a variability. So similar as before lah. Okay, we have central tendency and also the variation. Okay, so the information that we can get or the comment that we can write based on this diagram, average and also variability, but depends also in that question lah. Similar as what we discussed for the exercise for the measure of variation. Okay, if you have general question, okay, like before we have lifetime of the battery. Okay, so the question asks about which brand perform better. So general question that you can use either average or variability. Okay, unless you have specific term, special term. Okay, for example, which one is less consistent? So we know that the consistency belong to the variability. Okay, the word of the consistency belong to the variability. So we don't have any choice. We have to use a variability to comment that lah. Okay, but here we have a general question just to comment on the data. Flexibility of the spring is your variable, means that your data. So we just need to comment on the data. So you can use either average or either the variability lah, or maybe we go to the both. Okay, so how to know whether you need to do both or it is a one of that. Okay, another trick is to look at the mark that you have. Okay, let's say that you have about 4 marks. So 4 marks means that both must be there, average and also variability. Let's say that you just have 2 marks, then either one. Okay, so in statistics, another key is to look at the mark that you have for each question. 1 mark means that 1 point. Okay, 1 mark means that 1 point. Okay, so here it's up to you. We can do the average or the variability. Okay, so let's see both lah. Okay, so for the plotting, okay, you should have these box plots. Okay, you can have the horizontal. So in this case, we use the horizontal. Okay, or you can have the vertical axis. Okay, when we have more than one box plot on the same axis, you have to label. Okay, that box plot for which data set. Okay, so in this case, the first one is a company A. And the second one is a company B. Okay, if you don't label, then reader didn't know lah that box plot for which data set. Okay, and like before, we have to label the value that we plot. Okay, so we have the outlier here, mean, Q1, Q2, Q3, and also the max here. Okay, so similar to the company B. Okay, so the outlier here. And for when we have more than one box plot on the same axis, you cannot draw your box plot parallel to each other. Okay, you have to draw what we call different level. Okay, like this one. Okay, first box plot and second box plot. It cannot be parallel to each other. Okay, parallel to each other, it is like we mix around with the data. Okay, we mix the data lah. Okay, similar to the outlier here. Okay, so outlier for that data must be plot parallel to that box plot for that data. Okay, so here we know lah, okay, this outlier belong to this set of data. Okay, the box plot here represent the set of data lah, represent your data set here for the company A. So when we draw the outlier here parallel to the box plot of the company A, then we know this outlier belong to the company A. Okay, so outlier must be parallel to its box plot. Okay, if you draw this box plot to here, then we read this outlier belong to data of company B. Okay, so be careful that one. Okay. Any question for the plotting so far? Yeah. Okay, we go to discussion on the box plot. Also to answer this question. So we just the solution that we have here just one part of this of the solution of this question. Okay, so first we need to know the distribution because we try to compare the distribution. So distribution here means that the shape of your data. Okay. Okay. So first distribution. Okay, so here you just state what is the distribution of your box plot. So we have company A and then we have company B. Okay. Okay, so the shape of your box plot determined by the location of your median or location of the Q2. This one. Okay, so if the Q2 close to the Q3, then we have left skewed. Okay, in this case Q2 close to the Q3, then you have left skewed. Okay, in company B, your Q2 here close to the Q1, then we have what shape that we have here?
Positive skewed.
Positively skewed or right skewed. Okay, when we have your let's say that Q2 located at the middle of the data set. Okay, we have to consider this line, the line that connect the box to the min and max. If you have same length, then you will have symmetric distribution. Okay, that's the rule. Okay, how to determine the shape. Okay, so we have left skewed and right skewed. Okay, so that's first. And the second, we need to comment on the data. Comment on flexibility of the data. Okay. Okay, sometimes the question will be specific. For example, give comment on the flexibility of the spring based on variability. So you have to comment based on the variability. Or maybe give comment on the flexibility of the spring based on the average. Okay, so it depends on the question. In this case, you can use either one. Okay, so Okay, for the average, okay, so for the box plot to discuss the average, we always use the median or Q2 value. Doesn't matter what shape that you have, okay, because box plot is just a rough what we call a rough measurement that we use to discuss the data, because box plot is based on the visualization actually. Okay, how we discuss the data based on the visualization, so it is not really accurate, so it's just a rough measurement. That's why for the average here we use the median value or the Q2 value, okay, for the box plot. Okay, so we have Q2 for the A, 8.25. Here we have the unit, and then we have Q2 for the B. Okay, state the value first, 10.15. So why we need you to state the value? So that we know that we use the Q2. Okay, when you discuss the average. Okay, if you do not state the value, then or we cannot find any value stated in your comment, then we assume that you use the mean value or the average value, okay, the S bar value. Okay, that's why you have to state what value that you use. Okay, so first comment that you can write based on the average, you can compare these two values. So in this case, we have the Q2 of the A less than Q2 of the B. What we can conclude? Which one is more flexible? Which spring is more flexible based on the average value here? It is?
B.
It is spring B. So spring B is more flexible because the average value of B higher than the average value of A. Okay. So spring, you can write here, spring B is more flexible. Okay, the conclusion that you can write based on the average value. Okay, another interpretation that you can write based on the average value. Okay, another interpretation or another comment that you can write, the flexibility of the 50% spring A is more than the Q2 value. Okay, because in this question, it just comment. It is not to identify which one is the best one. Okay, so other than you compare and identify which one is the best one, we can write this kind of comment based on the average. In your opinion, is it correct if we write less than here? Is it correct if we write less than?
Yes.
Why?
50%, 50%.
Because median, when we have a data here, so median is a middle of your data. So the lower half here, it is a 50% of your data, and the upper half here is your 50% of your data. So it is correct to write more than or less than, because median here 8.25. So more 50% more than this value and also 50% less than this value. So it's up to you. You can write more than or you can write the less than. So similar goes to spring of the company B. Okay, you can write similar thing lah. Okay, comment pula. Question so far? Before we go to durability. Okay. Okay, the next one you can comment based on the verbability. So for the box plot verbability, we use the value of IQR. Okay, as I say, it's a box plot is a rough method that we use, okay, to comment on the data. Okay, so verbability we use the interquantile range. Okay, so find the IQRA and also IQRB. IQRA equal to IQRA, interquantile for the A, interquantile, guys,
1.5.
1.5. For the B,
1.2.
1.2. Where is the rest of you or only Devi is here? We have about 49 students here, but only 1 or 2. Only Devi just now and only Shahiran respond to me. The rest of you still here or not?
Still, madam.
Yes, madam.
So please participate. If you don't want to speak up,
Understand.
just write
Yeah,
on the chat. Okay, I need full cooperation from all of you. Okay, if not, I can have class with the Devi and Shahiran only. Okay. So we have the IQR, so similar to the average value, you can compare the value and then decide which one is a better one. Okay. So here, IQR of A greater than IQR of B. Okay, what we can conclude about the data? If we like that, we are going to talk about consistency of the data. What we can say about the consistency of the data based on the IQR here? Which one is more consistent?
B.
Is it?
B.
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 Dah cakap apa? Nak kena cakap dulu baru nak respon. Okay, so the data of B is more consistent. Okay, because B less variability. Okay, hence stream B is more flexible. Okay, so based on this, okay, doesn't matter what value that you use, the average here or the probability here, you have to come up with the same decision. Which one is the best one? Okay, based on the average, we get B, and also based on the probability here, you should get B. Okay, they cannot be contradict to each other. Okay, if contradict, must be something wrong somewhere lah. Okay, you have to check back your calculation and also how you interpret that value. Okay, both must come out with same decision, which one is the best one. Okay, cannot be contradict. Okay, other than we compare, you can just comment the data based on the IQR value. So IQR, it is between Q3 and also Q1. Okay, for example here, the spring A. So Q1 is 7.3 and we have Q3 8.8. Okay. So if we go back to the measure of position, IQR is about 50% of your data set. Okay, the distance from Q1 to the Q3, it is about 50% of your data set. So we can use that characteristic to comment the flexibility of the spring here. Okay, so you can say here flexibility. Okay, so we can write that flexibility of the 50% spring A is between 7.3 and also 8.8 because look at the distance between Q1 until Q3, it is about 50% of your data set. Okay, any question so far? So plotting is easy because I believe that most of you already go through the box plot before you come to this course. Okay, but the interpretation is crucial. Okay, not really crucial, but it is important. Okay, how we comment on the box plot, what kind of information that we can get based on the box plot. Okay, for the plotting, I believe that you can score full mark when you sketch the box plot. Okay, most of students, they will problem at interpret the box plot. Okay, so you can try the rest of the exercise and also the tutorial question. Before I forget, okay, so next week supposed to be quiz 4. Quiz 4 pula, quiz 2. Okay, so next week is a week 4, so supposed to be quiz 2. Based on the teaching plan, but some of my students from another section, but I trust in this section also lah. Okay, they still don't have the statistical table here. Okay, this one. Okay, the statistical table because chapter quiz 2 is about chapter 2. We have to use this table lah. So I will postpone the quiz 2 on week 5. Okay, so take note that quiz 2 will be on week 5. Okay, it is about 2.2. Okay. Okay, so we have 1.5 here, the last subtopic for the chapter 1. Okay, so normal probability plot is easiest method to check whether the data is a normal or not. So why we have to check whether the data is a normal or not? Because some of the method, they are only for the normal data. If the data is not normal, we cannot use those method. We have to go to the non-parametric method. Okay, so what we have in this course from chapter 2 until 6, they are for the normal data only. Okay, we call them as a parametric method. Okay, so that's why you have to check the data whether it is a normal or not. But for the study purpose here, we just assume that the data that we have in quizzes, in task, in final, and also module is a normal data. Okay, so for your assignment part 2, you have to check whether the data is a normal or not by using this plotting. Just a simple plotting. We plot the data, your data against the probability value. Okay, you can watch the video, that one. Okay. But if your data is not normal, you still can continue to the hypothesis testing lah. Okay, just exposure to you how to check the data. Okay, for when you go to the hypothesis testing, we assume that your data is a normal one. Okay, no need to go to the non-parametric, the line. Okay, so when you plot here, okay, if your data point here on a straight line means that most of your data, let's say that you have about 60 data value, okay, so most of your data on a straight line, then we can say that our data is a approximately normal distribution. It is not necessary all the data must be on the straight line. Okay, most of the data, if most of the data on a straight line, then we can say that our data is approximately normal distribution. Okay, if most of the data deviate from the straight line, not in a straight line, then your data is not normal. Okay, so plotting, it is based on the visualization, how we see that graph lah. Okay, so to confirm that, we have to go to the testing. Okay, so we have a few well-known tests for the normality. You have this Kolmogorov, Anderson, Darling, and also Shapiro-Wilk test. Okay, those we can use any software to conduct that test. Okay, to confirm that we really have the normal data. Okay, but for our course, we just use the normal probability plot, the easiest method that we use, that we have to check normal. Okay, so you can use this exercise, try to practice in your Excel. Okay, draw the normal probability plot and then comment. Okay, comment means that you have to comment whether the data is a normal distribution or not, approximately normal distribution or not. Question so far? Okay, so with that we finish chapter 1. Okay, if there is no question, I would like to proceed to the chapter 2. Just an introduction to the chapter 2, and then we end this class. Okay. Okay, so chapter 2 onward, there are inferential method. Okay, the one that we discussed in chapter 1. Okay, because chapter 2 onward here, we use the sample data to estimate the characteristic for the population. Okay, so chapter 2 is about confidence interval. There is no more sampling distribution. Okay, but in your module, we still have that section. But in what we call syllabus, where they take out the sampling distribution lah. So there is no more question about sampling distribution. Okay, so only confidence interval for the chapter 2. Okay. So we have about 7 subtopics that we need to cover for the chapter 2 here. Okay. So in general, confidence interval is a range of value. Okay, we construct range of value and then we assume that the population value lies within that range. Okay, so the confidence interval here we use to estimate the value of the population. Okay, we provide a range of value and then we assume that population value lies within that range. Okay, so we have 3 common value that we calculate in this course. We have population mean, we have the proportion, and also variance and standard deviation. Okay, so variance and standard deviation, they are related to each other. Okay, so we are going to estimate this type of value, population value. Okay, population mean, proportion, and variance. Okay. So what we have in chapter 1, we calculate the sample mean, we calculate the S, we calculate the S square. That one we call as a point estimate. Okay, point estimate to estimate the population value. So S bar is a estimator for the mu. Okay, so confidence interval is an interval estimate. Okay, we provide a range of value. Okay, so we provide a range of value. Okay, so the process to find the confidence interval, that it is a estimation process. Okay, in that process we use the estimator. So estimator is a sample value. Sample means sample, variance sample, standard deviation, or sample proportion, in order to estimate the parameter value. Okay, so hope that you can differentiate lah the terms of estimator, estimate, and also estimation. Okay. Okay, so I'm not going to discuss the theory here. You can watch the video, that one. Okay. We go to the 2.2. Okay. So starting this chapter, you need to have this statistical table lah. So please buy as soon as you can. This is the latest one. It is not necessary to use the latest statistical table. You can use the first version, which is silver one, or you can use the second version, which is orange one. Okay, the difference only on the formula. Okay, it is not general formula. It is in all the versions, but the new version here we have additional formula, especially for the one-sided confidence interval. Okay, so first we go to the population mean. So estimate the confidence interval for the population mean when population variance or standard deviation is known or unknown. Okay, estimate the sample size by using concept of confidence interval for the population mean. Okay, so by using this concept, we can estimate the sample size. Okay, population variance is known or unknown. Okay, this is where I said population and sample is very important. Okay, it is important for you to know how to distinguish the value given in that question. It is a population value or the sample value. Okay, because it will determine what formula that you need to use in that question. Okay. Okay, that's why if you already watched the video, the first step that I said, you have to extract the information. Okay, so based on the information, we decide, okay, which formula that we need to use, and also what parameter that we need to estimate. Okay, so what parameter that we need to estimate, then we know lah which formula that we have to consider. Okay. Okay, so we go to the formula. Okay. So confidence interval for the population mean, it will be mentioned in your question that you need to construct the confidence interval of something. Okay, that something will determine what parameter that we have. Okay, sometimes you will have a clear question, direct question. You have to construct confidence interval for the population mean or population proportion or population variance. Okay, sometimes it will be implicit somewhere what parameter that we need to estimate. Okay, so for the mu here, we have 3 different formula that we have to consider. Okay, so it is based on the information that we have in that question. Okay, so the first condition that we need to know whether sigma is known or unknown. Okay, so known here means that you have sigma in your question. Sigma or sigma square in your question. Okay. Unknown here means that you have only S or S square in your question. Let's say that you have both. You have sigma, you have S. For example, this example. Okay. So here you are given population standard deviation. So it is your sigma. A random sample of 9 packet. So you have sample of 9. So this is a sample data. So you have the data, then you can find your mean and also the variance. Okay. So the mean that you calculate here, what notation? For the mean that we calculate based on the data here? It is notation
S.
S bar.
S.
Okay,
S
S
bar.
bar, not the S. Okay, if we calculate the standard deviation here, what notation that we use?
S.
S. Okay,
S.
so in this case, you have both. You have sigma and also you have S. So which one that we need to use? Sigma or S? We need to go to the first condition or the second condition. Sigma is known or sigma is unknown. You have both value. Known. Why we use known? What means that we use sigma here in our calculation. So why we use sigma in our calculation? Why don't we go to the S? Why? Why? It is known. Okay.
Sigma is provided.
Okay. So I know that. Okay. It is known because of we have sigma, but at the same time we have S also. So we have two conditions here, whether sigma is known or unknown. So why we choose to use sigma, not the S?
Because the mean value is given.
Because what? The mean or the main
The mean value is given.
value is given. Close to, but not really accurate reason. If there's a, let's say that we have 2 mark on that question, maybe you just get one mark.
The n is larger than
Not related to the n.
not related.
Not related to the n. Why we go to the sigma? We have both. It is correct to use a sigma. I don't say that it is not correct. It is correct that we use a sigma in that case. We have both value, which is sigma and S. It is correct we go to the sigma. But I need to know why we go to the sigma. I need to know, you have to know. Sigma represent the whole population, while S represent the sample only. So means that it is correct what your friend just said right now. Okay. Another word is sigma is a true value to use because sigma represent the whole population. Okay. While S is just approximate value. Okay, that's why when we have both, we go to the sigma because sigma again is a true value to use. Okay, and S is a approximate value. Okay, that's why we go to the sigma. Okay, back to the theory from chapter 1. Okay. Okay, so when you have sigma, then we go to the first formula here, formula with the sigma and also the Z distribution. Okay, when sigma is unknown, we have the second condition that we need to determine. It is the sample size, whether we have larger, whether we have small sample size. Okay, when we have larger sample, means that n greater than equal to the 30, then we use the second formula here, formula with the S and Z distribution. Okay, and the third formula for the n less than 30, formula with the S and T. Okay, so there's a keyword in this formula. Why we have S here? Because sigma is unknown. So we know lah, okay, this formula for the unknown. Okay, larger sample always use Z distribution. Smaller sample we use T distribution. Okay, formula for the sigma here, it is for the known. Okay, because we do have value sigma in that question. Why it is important? Okay, for those who already have this statistical table, you can refer to it now. Okay, for those who still do not have this one, okay, as when you get yours, then you can watch this video lah. Okay, because I record this session. Okay, if you turn to the page 5, we have the formula. Okay, starting from page 5 until page 9. Okay, there are formulas from chapter 2 until chapter 6. So no need to memorize, but the formula here, it is not complete as in the module. It is not complete as in this line. Okay, because, okay, so the page 5, we have 2 columns. The first column, it is for the chapter 2, formula for the chapter 2, confidence interval. You can read from here. Confidence interval for the mu. So the formula that we just discussed just now. Okay. And the second column here, they are for the chapter 3, hypothesis testing. Okay, started here, hypothesis testing for the mu. Okay, so we refer to the formula of the confidence interval for the mu here. Okay, we still have these 3 formula as what we discussed just now, but it is not complete as what we have in the module and also the slide. Okay, here it didn't mention which one for the sigma is known, which one for the unknown, which one for the n greater than 30, which one for the n less than 30. Okay, you have to know by your own. Okay, that's why I said the keyword in the formula, when you have sigma, then it is for the known. Okay, because we need to replace or substitute sigma here with the value of sigma, not the S. So it is for the known. Okay, when you have formula with the S, then you should know that sigma is unknown. Formulas for the sigma is unknown. Okay, Z distribution here for the larger n and T distribution here for the smaller n. Okay, so practice yourself to use this statistical table when you do your exercise and tutorial and so on. Okay, because during the assessment, okay, quiz, test and final, the only table that you can refer only this one. Okay, the only table that you can refer only this one. Okay, obviously you cannot, it is like our it is like us in class. Okay, you cannot refer to the module or any sort of what we call sources. Okay, so the only one that you can refer is this statistical table. So practice yourself to use this statistical table, okay, so that you know how to read the formula from statistical table. Okay, okay, so done with the formula, we go to how to find the value of Z and also T distribution. Okay. Okay, so for to estimate the mu, we use 2 distribution. We have the Z distribution, and then we have T distribution. Okay, to read the Z distribution, okay, so these 2 value come from this statistical table. Okay, we call them as a critical value from this table. So you should know how to read your table. Okay, so to read the Z distribution, we need the probability value. So in our case, we have Z alpha over 2. That's our probability value, alpha over 2. Okay, to read the T distribution, we need two values. The first one, probability value. So in this case, in this formula, we have alpha over 2 here. Okay, the alpha over 2. Okay, so refer to your formula, what value that we need. And also the degree of freedom, which is no. So degree of freedom based on the formula here, it is n minus 1. So sample size minus 1. Okay, so for the T distribution, we need these two values. It is a package for the T. Okay, in order to read the T distribution from the statistical table, we need these two values, probability value and no. Okay, degree of freedom. So what is our alpha? It comes from confidence level, the percentage of our confidence level. Okay, because confidence level is a probability that represents the range of value that we are going to calculate. So let's say that we need to find 95% confidence interval. So probability value, the alpha come from this confidence level. So it is 1 minus alpha equal to 0.95. So alpha equal to 0.05. But what we need, alpha divided by 2. So we have 0.025. So we need here Z 0.025. Okay, for the T distribution, we need alpha divided by 2, 0.025. The new degree of freedom, let's say that we have 10 for the n. So n minus 1, we have 9. Any questions so far?
No,
Okay. Okay, if you have this table, so go to the page 36 for the Z distribution. Okay, so different version, we might have one page different. Okay, but you just need to find table 4. Okay, doesn't matter what version that you have, you just need to find table 4 for the Z distribution. Percentage point of the normal distribution. Z distribution represent normal distribution. Okay, so what we have here, column, it is an alternate column between the alpha and also the value that we need. Z alpha here, the value that we need, and then repeated alpha, Z alpha, alpha, Z alpha. So what we need to do, we find 0.025 from the column of alpha. Okay, 0.025 from column alpha. What value that we have for the Z?
1.9600.
1.9600. Okay, so if you have your own table, please refer to it now. If not, you can always watch this video later. Okay, all of you need to know how to read the value from this table. Okay, for the T distribution, the next page after that, page 37, it is in table 5. Okay, table 5, percentage point of the T distribution. Okay, so the first column here, that's your new degree of freedom. In our case, 9. The first row here represent probability value. So we need 0.025. So find the combination of 0.025 with the 9. So what value that we have?
3.6897.
Again, carefully, look at carefully. We need 0.025
0.25. Okay.
with 9.
2.2622.
2.2622. Okay, it is a basic one to read the value from this table. Okay, we will use the critical value here until we go to the chapter 6. Okay, so you should know how to read the value from here and also how to read the formula from this table. Okay, so this is why I postponed the quiz 2 lah. Okay, the quiz 2. Because we need to use some value from here. Any questions so far?
No, madam.
No, madam.
I feel like I am the storyteller. Yeah. Okay, so exercise 2.1, you are supposed to do number 2 and also number 4. So it is already 3:50. We postpone next week. Is it okay?
Okay, madam.
Okay, madam.
Okay, madam.
Okay,
Okay,
madam.
so we postpone the exercise 2.1, number 2 and number 4 next week. We discuss before the subtopic for the next week lah. Okay, so we still have time to do the exercise. If there is no question, that's all for today. And see you next week. Thank you, class.
Thank you, madam.
Thank you, doctor.
Thank you,
Thank you, madam.
madam.
Thank you, madam.
Thank you, madam.
Okay. Stop.
Thank you, madam.
Okay.